This is Dr. Obulakonda Reddy, Professor, Department of CSE Cybersecurity. Today we will see the network services and communication software. I was collected information from these sources. Now see network services and communication software. So communication in first, these are two things from network. What are the network services will use to the cluster computing, and communication, what type of communication softwares, communication should be given to a cluster. First we focus on the communication. So communication infrastructure support protocols are bulk data transport, streaming data, and group communication. Now see, what is the bulk data transport? We have to transmitting a group of data into a network. So here bulk data transport. In a network services, bulk data transport in network services refers to the efficient and reliable transfer of large volumes of data between network devices or systems. So large volumes of data between network devices or systems. So what is the goal? Main aim of this bulk data is to optimize the throughput and minimize the latency, the delay. We have to minimize the delay and optimize the throughput. Throughput means the number of jobs completed a particular amount of time. So throughput. Our intention is large bulk of data has to be transferred through a channel, through a network. So what is the advantage here? Throughput. Number of jobs has to be completed with a particular amount of time. At the same time, minimize the latency, delay we have to reduce it, and ensure data integrity during transmission. While transmitting the bulk data, we have to, in between, for example, consider the system like this. This is the one system. Assume that this is the another system. Okay, now we can transmit from here to here. Bulk data. So large amount of data, bulk data has to be transferred in between from system 1. Assume that the system 1 to system 2, source to destination. In between these two, we have to transferring a bulk amount of data between network devices or system to systems. Network devices or system to system. So now what is our goal? So optimize the throughput. So particular amount of time, number of jobs has to be completed. At the same time, minimize latency, delay time has to be reduced, and data integrity during transmission. So for achieving bulk data transport, we can see here protocol selections. First one, protocol selections. Generally, we transmit in a network the protocol to use TCP/IP and UDP. So transmission control protocol, internet protocol. This is the first one, and second thing is a UDP. User datagram packet. But in the protocol selections, so once we have to use for TCP/IP protocol, which has to be a reliable, the data transmission from source to a destination, it is a reliable and guaranteed to deliver the destinations. In case if you are used for TCP/IP protocol, but in case if you have used for UDP, this is also fast data has to be transferred, but there is no guarantee transfer in between from source to a destination. So that is the protocol selections. What if it is selecting for TCP/IP, it is a guarantee to deliver the from source to a destinations. And the data compressions. This is the second thing. So bulk data transport. Remember these points now. So protocol. What type of protocol you have selected? So either TCP or UDP. And after protocol selections, data compressions. So the bulk data, we have to send a redundancy data, that is a waste of spaces. So we have to compression, that before sending a data in a network, we have to compress a data. Without loss of original thing, it has to be compressed data. So that is the data compression. Compress the data. So that will be achieved with a bandwidth. That will be take a less amount of bandwidth. And third point, parallelism. So here large number of data sets has to be divided into a chunks, a small set of chunks. So for example, it is a large amount of data. Assume that now it has to be divided into a small chunks. What do you mean by chunks? So it is a set of data that has to be sent to a processor. Whatever. If you have a processor, the set of data has to be sent to a processor. That is called chunks. So now here large set of data has to be divided into small chunks. 1, 2, 3, 4 up to like this 100 something. We can divide it. The large number of data has to be divided into a small set of chunks. It is nothing but the set of data has to be sent with a processor. Set of data has to be sent to a processor. So here parallelly in sense. So all here 1 to 100 chunks is there, that will be parallelly sent to a distributed environment. 100 chunks has to be sent with a different process. So that time it has to be achieved with a parallelism. So that is impact with a bulk data transfer. Next, buffering and flow control. Buffering. For example, if you take as from source to a destination system, assume that source and this one is a destination system. Then sources has to be send faster. Sometimes it may be send a data to a faster, and the receiver may be a slow. So in between, it's required for a one buffer space. Buffer. Storage packets. Store data into a buffer. Small storage area. Buffer is nothing but it is a small storage area to store in data into here for controlling of flow control. Flow control purpose. Controlling data in a network. So we have to maintain a buffer. Either fast sending, the sender may be send a fast data that will be stored in a buffer. Later it has to be sent. Sometimes it may be the sender may be send a slow data that is also stored into a buffer. That data has to be sent with a server. So these cases the buffer it is a temporarily streaming. Whenever we go for a streaming of data, the buffer will help that. Temporarily we hold a packets in the buffer. Next thing is error detection and corrections. While transferring data in between from source to a destinations, so now error detections and corrections that has to be focused to. So now in case of error, in case of any duty packets will be failed, that has to be resent to a those packets we have failed, we have lost. Again resend it, retransmit the data. So that will be error detection. Whatever the error we get in networking, that type of error we have to rectify, and detection and correction. Detecting what type of error we have encountered, then that has to be rectified. And other thing is network optimizations. Like we have to take for a router switches, we have to optimize the networking also, cables. That will also improve the send the bulk data transmissions. So router switches, cables, something you have to optimize the all network related things. And next one is a data duplications, redundancy. No need to send a same data has to be sent a number of times. That is a waste of bandwidth. Then two, data duplications. Like here duplication is there now, we have to avoid it. In case if it is sending, there is no use of that. So you have to focus on data duplications. These all things will be focused to a sending bulk data from network devices or system to systems. So next thing, streaming a data. So this is the second type of communications. Now streaming of data. So while streaming data in a network services refers to the real-time transmission and delivery of continuous data stream from a source to a destination over a network. So it is a real-time transmission and delivery of continuous data streams. Stream of data, flow data. Like for example, if you take as one system, assume that this is a one system and this is the other systems. So we have to flow of data in between from node to node. So refers to the real-time transmission and delivery of continuous data streams. Stream says the flow of packets has to be transferred from here. And the other thing is Streaming data is commonly used in applications such as live video audio streaming. For example, our video conferencing or conducted any meetings. Then the time it has to be a live audio video streaming. The packets, the total data has to be divided into in the form of packets that has to be streamed, continuously streamed. So generally we observe in live shows also. So that will be, so whenever you capture data, immediately that has to be the data has to be in the form of packets that is continuously transferred from source to a destination. And the real-time analytics, financial market data feeds, IoT, Internet of Things, sensor data, whatever you read through a IoT sensor data that has to be streaming, and online gaming also. So these are all the things that has to be used with the stream data. And what are the protocols to use for this? For streaming of data, continuous transferring of packets from one place to other places. Live shows, we have video conferences, like we can watch with a video conference. Something you can send live data, then that has to be streaming, continuously streaming. Packets of data has to be transferred. And what type of, for achieving of this one, what type of protocol to use? Here, protocols are real-time messaging protocol, RTM. Real-time messaging protocols. That is sent with a like good example is live audio video stream has to be sent with a video conferences, like messaging, real-time messaging protocol. And the second thing is real-time transport protocol, RTP, real-time transport protocol. It has to be a deliver audio video in IP network. Above one is messaging, this one is a transport protocol, real-time transport protocol. And next one is HTTP live streaming, HLS, HTTP hypertext transfer protocol, live streaming, like it has to be deliver data to web browsers or mobile devices. So the type of protocol to use for HTTP live streaming, HLS. And the second type we observe here, second type of streaming data is data encoding and compression. Data encoding and compressions. So encoding in the sense the text has to be converted into other form, and then later it has to be compressed. Compressed in the sense the data has to be reduced. For example, it may be a 10 KB of spaces that has to be reduced with some 7 KB or 6 KB something. It has to be reduced. Then after that, first it has to be encoded and compressed. So compression in the sense the data has to be reduced. That may be improve the performance of a bandwidth. And then data encoding in the sense one text has to be converted into other form, encoding. Then second type you would use data encoding and compression. And third one, see here, buffer and latency management. Already we'll discuss about the buffer. What is the buffer here? So from sender source to a destination, in between it has to hold with one small storage area. Like it has to be send data to, the packets has to be transferred to a destination. In between it has to be hold with a buffer. Buffer is nothing but it is a small storage area which has to be controlled with a flow of data in a network. So now in a buffering, that's whatever you send, that packets has to be stored to here. Then the packets, streams of packet has to be sent with a destinations. Again, whatever send a sender, that will be loaded to here. Some time is getting to here. Sometimes maybe a slow in network failures or something happened, that the data has to be stored in the buffer, that will be sent to a destinations. Latency management. So latency in the sense delay. We have to reduce the delay. For that one, we have to use some techniques. Security and encryption. Fourth one, we observe that security. Stream while going data into a networking, we have to provide security to that data stream. This is a very important. Otherwise, it may be lost our original thing. So for that one, we have to use different security mechanism, RSA, some different advanced mechanism we have to apply for security. And encryption also. So encryption in the sense that code has to be converted one form to a other form, plain text to ciphertext. Then real-time analysis, real-time analytics and processing. Real-time example you can take for a real-time example, and those has to be a processing. So these are all the things that should be a streaming of data that will be help for a streaming data. This is the second thing. And third, we discuss with the third thing, group communications. So here, what do you mean by the group communication? So now first the definition, group communication in network services refer to the transmission of data or messages from one sender to multiple recipients simultaneously. Transmission of data or messages from one sender to multiple recipients simultaneously. So that is called as a group communication. So now in that group communication, we have to observe with the different categories: multicast communications and IP multicast, broadcast communication, group messaging applications, security and access control, reliability and redundancy. Multicast. So here multicast in the sense that will be sent to a different devices or different systems. At the same simultaneously, we can send a data to a different systems. Multicast. Same time we can pause. IP multicast. For this one, use for a IGMP, Internet Group Message Protocol. IGMP. This is a IGMP is one of the protocol which has to be supported with IP multicast. That has to be a sending packets to in between routers to routers. So router is that will be decide a routes to a packets. Decide a routes to packets. Now IP multicasting, this which has to be used for IGMP, Internet Grouping Message Protocol, which has to be focused in between router to router. The packets are delivered properly or not. So in between IP, it has to be a multicast. For this one, used for IGMP. Next, broadcast communications. So similar IP, for example, the IP address may be a 255.255.255 common IP address. So whatever we send this content, which has to be parallelly, it has to be distributed. So broadcast. So similarly, broadcasting to different devices. So same thing has to be broadcasting with the different devices like our team. Okay. So group messaging applications. The fourth thing we have observed that group messaging. So in a group, parallelly we have to communicate it with a different persons. So that is a group messaging applications. And security. So this is the very important concept for transferring of data in a group. It has to be maintained the security. That is the very important thing. Then access control also. So authenticated. So this access control is also very important. And then reliability and redundancy. So that is reliable. Whatever to use a group communication, that has to be a reliability. So that will be see the reliability also. And then redundancy, duplications. Most of the duplication we have to avoid it. So this is the another thing. Next, this is the latency is a second type things coming to the back here. So here latency. So second, up to this point we have see with 3 points: bulk data transport, streaming data, group communications. Again, the communication service provider cluster with important quality of service parameters. So communication quality of service parameters. What are those? Latency, bandwidth, reliability, fault tolerance, jitter control. Again, see this one by one. Latency. Second type of communication quality of services, latency. What is the latency? In simple terms, we say that delay. So delay or time interval. Delay or time interval between the initiation of data transmission means starting point and the receipt of corresponding response acknowledgement. So that is told to as a definition of a latency. In what type of observe the different types of latency. So here propagation. First one we discuss with the propagation delay. So propagation delay is the time it takes for data packet to travel from sender to the receiver over the physical medium. So data packet to travel from the sender to the receiver over the physical medium. So propagation delay, like examples are copper cables, fiber optic cables, or wireless links. So the propagation delay in between the physical mediums. The packet to travel from the sender to the receiver over a physical medium. That has to consider with a propagation delay. And the second thing is a transmission delay. Transmission delay occurs when data packets are being transmitted over the network links. Just data packets has to be transferred in between a network links. It is influenced by factors such as packet size, data rate, that will be impacted with the bandwidth, and network congestion, network traffic. So this is the thing with transmission delay. And third thing is processing delay. So now this delay includes the time taken by network devices. So what is the time taken by network devices? Like routers to decide the routes for packets, switches, or gateways to process and forward data packets. So processing delay, how much of time to take for that particular network devices. So that is comes under processing delay. And next one is a round trip time. Simple short form to write as a RTT. RTT is the total time takes from data packets to travel from sender to the receiver and back again. So that is take as a round trip time. The sender, the data packet to travel from sender to receiver and back to the acknowledge. Back to the acknowledge. So we receive so and so data has to be received here. From receiver we get receiver to we get as a acknowledge. So this type is called as a round trip time. So this is a guarantee. After delivering guaranteed delivery, that has to be sent acknowledged to a sender. So this is the different types of latencies we have seen. Next thing is a bandwidth. What is the bandwidth? A number of times we use this word in high performance computing, bandwidth. What do you mean by the bandwidth here? Bandwidth refers to the maximum rate of data transfer over a network connections. Maximum rate of data transfer over a network connection. So typically it has to be measured in terms of a BPS, bits per seconds, or kbps, kilobits per second, kbps, or mbps, megabits per second, and gigabits per second, gbps. The transferring of data, maximum rate of data transfer over a network connection. So that will measure in terms of a BPS, kbps, mbps, or gbps. And other definition in simple terms, bandwidth is like a width of pipe through which data flows. Higher bandwidth allows more data to flow through the network and enabling faster data transfer speeds and support activities such as streaming video, downloading large files, online gaming, and web browsing. And next thing is the outline of this slide will tell about reliability and fault tolerance. What do you mean by the reliability? So see here, network services refers to the reliability in network services refer to the ability of a network or network system to consistently and accurately deliver data. This is the very important. Reliability, accurately deliver data, or services, max up to maximum services, or resources without disturbance, disruptions, or errors or failures. Ability of network or network system to consistently and accurate deliver data, services, or resources without errors or failures. So that is called as reliability of a system. That don't be failures, and then don't be produced as error, any disturbances, without any disturbances, and accurately delivery data, and it has to be provided services. Next thing, what do you mean by the fault tolerance? Second, fault tolerance. Always here observe that the system failures, always it has to be provided. Sometimes the network due to a certain network failures, the system may be failed, but during that one, it has to be identified, correcting those errors. Again, it has to be start with a normal stage. Then now fault tolerant architectures and protocol ensure continuous operations and services availability dispute hardware or software failures. Continuous operations and service availability dispute, continuous hardware or software failures. So this is a fault tolerant architectures. Next thing, jitter control. What do you mean by the jitter? So jitter refers to the variability or fluctuation in a latency over time. Sometimes it may be a fluctuations occurred in a networks. Due to that one, it has to be disturbed with a different thing. It may be varying. The result may be varying. Network conditions may be changes, and conjunction changes. Conjunction is nothing but it is a traffic. That may be a traffic. Maybe a changes. The routing decided. That may be a changes. Or packet rendering, reordering. That is also a changes. And this excessive jitter can degrade the quality of real-time applications by causing inconsistent packet arrival times. So this is a drawback in network systems. We have to controlling the jitters. So variability or fluctuations. So we have to apply different mechanisms. We have to overcome the jitters. Coming back to here, up to this point we have to see here communication only. So communication part we have discussed. Then we'll see the network services also. So network services that has to be providing RPC, remote procedure calls, and DSM, data stream mechanisms. In the network services, we have to study with the RPC or DSM. You can see here. So first one up to this point we study with a, up to this is discussed with a communication only, communication softwares. In the first level, we have to discuss with bulk data transport, streaming data, group communication infrastructures. And second thing, quality of service parameters, latency, bandwidth, reliability, fault tolerance, jitter control. Now we discuss with the network services. What are the two we see here, RPC, DSM. So this is network services. Now RPC, remote procedure call. This is short form we write as RPC. So that will focus on, just like RPC is nothing but it is a client servers. So the data has to be sent with a client to RPC mechanism. Mostly we have to use for a client server architectures. Now in this first one we will discuss with a client server architecture. RPC follows client server architecture where the client initiate a request. For example, we assume that this is think as a client system. This is the other side which have a server system. This is a client. This is a server. Now request. The client has to be raise a request to a server. The server has to be take that request and process, again send result back to the client. So this is RPC, remote procedure call. So the client initiate a request and the server processes the request and send back to response. So this is the mechanism we have observed in a client server architectures. And the second thing is stub and skeleton. What do you mean by stub? Client side. We have write as a client side thing. That is we call as a stub. Stub is nothing but client side. And skeleton, that is called as a server side. This is the skeleton. So now these are used to facilitate communication between the client and servers. And third type is serialization and deserialization. The RPC framework and the serialization, converting. What do you mean by the serialization? I want to send in, for example, this is assume that one system. The system has to be transferring data into through a proper channel. Then the data, converting data into a format suitable for transmission over the network. What the format it has to be supported. It may be IPv6 or IPv4 version 4. So which has to be supported. The data has to be transferring into in that format. So that is called serialization. Converting data into a format suitable for transmission over the network. In a client side, for example, we are used for IPv4. Now here is the IPv6. Now we have to convert it with the data in the serialization. IPv4 version has to be converted with the IPv6. So converting format, which is the transmission, the data format has to be changed. And the deserialization in the sense, converting at the receiving end, the data has to be transferred from this network. After that, at the receiving end, it has to be a deserialization, converting received data back into the original frame. So this is the things, serialization and deserialization. Again, it has to be sent whatever we have to previously converted it. Initially it is IPv4, but it is changes with IPv6 serialization. It has to be transferred into a destination. Again, it has to be read back to a original form. Like IPv6 to finally it has converted with the IPv4 format. Then it is changes with the IPv6 to v4. So this is the mechanism we follow with the RPC, remote procedure call. And the next thing is the DST, data streaming technology. So streaming, previously we discussed with the streaming in the sense the flow of data has to be transferred through the network. So in streaming, DST, data streaming technology, the DST may also refer to data streaming technology, which involves efficient transmission, effectively you have to transmit your data, and processing of streaming data at network services. These data streaming technologies are crucial for real-time analytics. It's very difficult to finding for real-time analytics, and content delivery networks, CDNs, and multimedia streaming applications. So this is the part we discussed with the data streaming technologies. So RPC and DSM mechanism, these two has to be discussed with the network services. So implement wide range of communication methodologies. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.